All right, so today we are going to talk more specifically about that vertex. So yesterday we talked about the vertex being the center point of our parabola, of our graph. So we're going to talk more specifically on how to find just that so that we can use it to do some graphing shortcuts later in the week. So first we have to talk about zeros of our function. So a zero of a function is an x value that makes the function equal to 0. So we talked about this very briefly when we were factoring. On a graph, these values would be the x-intercepts. A quadratic can have 0, 1, or 2 zeros. Most often it'll have 2, just like you would have 2 roots in a function or 2 binomials in a function. It can have 1 if it was one of our special product where you have a difference of squares or a perfect square trinomial, or it could have 0 if it's not factorable. So or has no solutions. So 2 is most common, but it could have 0 or 1 zeros as well. So here's some picture examples of what that would look like. So for A, this would have 2 zeros because it crosses twice. And it says find the zeros. So I'm going to say that my zeros are x equals -1 and +2. That's where it touches my x-axis. And if I were to factor this, these would be the solutions I get out. And we will work on that piece of it later on in our unit. Here on our graph, this would be an example of what 1 looks like. In this case, our 0 is +1. And then on C, it doesn't touch our x-axis at all. This is an example of there being no zeros. Okay, so 2, 1, or none. 2 would again be the most common. Axis of symmetry. So we need to talk about this because it's going to be our x value in our vertex. So axis of symmetry says it divides the parabola into 2 symmetrical halves. So it's a dashed line that's going to go right through the center that makes your parabola really into 2 mirror images. So we're finding the middle. So to find the axis of symmetry, if you have 1, 0, it's just the x-coordinate of that vertex. So this would be an example where it only touches our x-axis once, and our axis of symmetry is going to go right through the middle there. If we have 2 zeros, you just need to find the average or the middle of those two. So here between -2 and +4, that's what it looks like. -2 and +4. Our average would get us to +1 here. Because -2 + 4 is 2, 2 divided by 2 is 1. There we go. Right in the middle will be +1. Remember, a vertical line that crosses the x-axis is written in the form x equals blank, blank being the number. So in this case, we would have x equals 1, and in this case, we'd have x equals 3. So this is how we write our axis of symmetry. So finding the axis of symmetry on our own here, this parabola would be divided right through the middle at 2. So we'd put x equals 2. This one would be right here at 3, it looks like. Okay, you can also average your zeros here where you have 1 + 5 is 6. 6 divided by 2 is 3. But a lot of times when you have a graph, it's pretty easy to figure out where it would be just visually. All right. So when a function has no zeros or they're difficult to identify a graph, we can use this formula where we have -b over 2a, where we're using our standard form. So b is the coefficient of x, a is the coefficient of x squared. So if this was our trinomial here, we would take -4 over 2 times 2 to get -1. And this is most helpful when you don't have a picture. That's mostly when I use it. When you have a picture, usually it's pretty easy to identify visually. So here we're going to find the axis of symmetry. Remember, we're using standard form, meaning we're using y equals ax squared plus bx plus c. And your axis of symmetry is negative b over 2a. So in this case, so let's just label a, b, and c. A is 1. There's no coefficient here, which means it's a positive 1. B is 3, and c is 4. So I want negative b over 2a. That'd be negative 3 halves. So our axis of symmetry is x equals negative 3 halves. Okay, on this example, we have a equals 2, b is 1, and c is 3. So then we have negative 1 over 2 times 2 is negative 1/4. So our axis of symmetry is x equals negative 1/4. Okay, so that's how you find our axis of symmetry or the x-coordinate of your vertex. So now we're going to take this axis of symmetry part one step further so we can find the vertex of our parabola. So here's the steps. First, you want to find the x-coordinate of the vertex by finding the axis of symmetry. So we already know how to do that part. That's what our last few examples were over. Then for step 2, we're going to find the y-coordinate by plugging that x-coordinate back into our trinomial. And then last step is just to write it as an ordered pair. So we'll go ahead and do a couple of examples. This is our last slide for today. So on this one, I have a is negative 1, b is negative 2, and c is 0 in this case. And I'm trying to find my axis of symmetry first. So that's my negative b over 2a. So in this case, I'd have positive 2, we're changing the sign, over 2 times negative 1, which is going to simplify to give us negative 1. So we know x is negative 1. That's step 1 in our steps to find the vertex. So now we're going to move on to step 2 and find the corresponding y-coordinate by substituting the x-coordinate back in. So I'm going to take this negative 1 and I'm going to plug it back in for x. So we'll have to plug it in twice here. So I'll have my negative in front of my x squared, and then I'm plugging in my negative 1. So here, negative 1 squared is positive 1, but I still have this negative in the front, so I'm going to end up with a negative 1 plus 2, which is positive 1. So now I know my two coordinates. My final answer for my vertex is negative 1, 1. All right, one more example. In this case, a is 5, b is negative 10, and c is 3. So first we have to find our axis of symmetry. So negative b would actually be a positive 10 over 2a. So this is going to simplify down to be positive 1. So that's my x-coordinate. So I'm going to take this 1 and I'm going to plug it in for x in my trinomial. So we have y equals 5 times 1 squared minus 10 times 1 plus 3. So this will give us 5 minus 10 plus 3, which should be negative 2. So my final ordered pair is 1, negative 2 for my vertex. All right, so that's how you find the vertex of your parabola. You do have a short delta math assignment to work on.